Euclid's 26th proposition says that given two triangles, if two of their corresponding angles are equal and any one of the corresponding sides are also equal, then the two triangles are congruent. Now here we will end up with two different cases. One is when the corresponding equal sides are between the angles and when they are not. So let's take these two cases separately. So first we will prove that AB is also equal to DE. And then we will prove that AC is also equal to D. So here let's assume that AB is not equal to D. Now naturally, which means if they are not equal, that means there has to be some point at which it will be equal. So let's bring in that point G and let's draw a segment GC. So here, since we are assuming AB is not equal to DE, we are assuming that BG is equal to DE. Now, if BG is equal to DE, that means what? This side is equal to this side, this angle is equal to this angle, and this side is equal to this side. That means based on the proposition of side angle side, we can say that this triangle is congruent to this triangle. Now since these two triangles are congruent, that means what? That means angle ACB is equal to EFD. It is given to us. But because GCB and DEF are congruent based on our assumption, then angle GCB is going to be equal to DFE. Since this angle GCB is equal to DFE and this in turn is equal to ACB, that means what? It means that angle ACB is equal to GCB. But that is not possible. Why? Because two line segments, that is AB and GB, they cannot subtend the same angle. And because of this, we have reached a contradiction. That means our assumption that AB is not equal to DE is false. So which means we can say that AB is equal to DE. So that means we don't require these two. We have proved that AB is equal to DE. Now, using one of the previous propositions of side angle side, we can say that these two triangles are congruent. Yes. That means what? That means AC is also equal to DF. AB is equal to DE. AC is equal to DF. And because of the congruency, this angle is also going to be equal to this angle. Now let's look at the other case. Here, again, two corresponding angles are equal to each other. And a side which is not between these two angles is also equal. So now again we have to prove that these two triangles are congruent. Again we use proof by contradiction. So let us say BC is not equal to EF. That means there must be some point on BC which will make it equal to EF. So let's identify that point and draw this line segment AH. Of course, here as we are taking it here on BC itself. This point can be taken outside by extending BC. So here we are assuming that BC is greater than BH. So which means what? Which means that this triangle ABH is congruent to DEF using side angle side, which is one of the propositions we have already proved. Okay, which means what? Since this triangle is congruent to this triangle, we can say angle AHB is equal to DFE. But we are already given that ACB is equal to DFE. Remember, equal to and congruency means the same thing. Which means, since this is equal to this is equal to this, we can say that angle ACB is equal to AHB. Again, which is a contradiction. Why? Because, again, the same proposition. So here you have one line segment which is subtending this angle and this angle, which are different. So you can't have that. And this we have already proved in one of our previous propositions. So because of this contradiction, we can say that our original assumption was wrong. That means BC is not equal to EF is wrong. So which means BC is equal to EF. So which means we don't need this now. Similarly, we can show that AC is equal to DF. So which means that this triangle is congruent to this triangle based on side angle side, which means all the other corresponding sides and angles are also equal. So that is proposition number 26. Again, let me remind you, there is a link to a PDF book where I describe all the 48 propositions of Euclid's book 1 of elements. That's it for now. Bye.